ahead. So does it look good like this with the light?
You can try turning down the light if you want. Where's the other one? Much better, thank you.
Okay. Good afternoon. Today we're gonna talk about the final design for the project. As you can see here, we're going to talk about the design and construction plans of CGN, which is this one, located on Metro Expressway and Local Expressway.
Hi, I'm Rafael Medina. I'm one of the transportation engineers for this project. And I'm going to talk about a little bit of the alignment of the bridge 9. For the vertical curve, I used to have a gradual change, tangent change from one grade to another. Now here, when we said on the proposal about our vertical proximity to the airport, it didn't actually affect this bridge because this bridge is more to the south of the airport. So, but it did change our clearance because it affected the first one, which is the Palmetto. So that affected the other levels, which Bridge 9 falls into the level 4 of these 4 levels. Now, the only requirement that we had was the clearance between each level, which is 16 feet 6 inches on the highest point of our bridge of the height. That gave us a PVI elevation for a vertical curve of 107.502 feet. We can see over here, that gives us a point intersection of the curve for the vertical. Now for the horizontal alignment, we have three curves. We have 2 spirals and 1 regular curve. The actual bridge starts on a straight path, and then just before Pier 3 to Pier 5, before Pier 5, we have a spiral, or first spiral curve. Oh my bad. A spiral curve, which is the northwest to B, that starts at the station 2840 plus 7931, and it finish at the 2843 plus 8651 with a point intersection of 2842 plus 4825. Then it picks, it joins with the regular curve just before Pier 5 that goes all the way to just before Pier 14, and that starts where my spiral left off, which is the 2843-8651, and it ends on the station 2862-52 plus 52.66 with a super elevation of 0.064. And then it's the last one, which is the last spiral curve, which is the 2A, and that goes, like I said, from just before Pier 14 all the way to the embankment of the bridge. And it finishes in the station 2865 plus 5986 with an point intersection of 2863.50 plus 55.18. Now my engineer will follow.
Hi everyone, I'm Gaini Ray. I'm the other transportation engineer for the project. As you can see here, this is the typical section of the bridge, which is in accordance with the design specifications of the department. The bridge is going to have 2 travel lanes, each one of 12 feet, a left shoulder of 11 feet and a right shoulder of 8 feet. It's also going to have a super elevation of 6.4%, a grade of 412.36, and the maximum radius in the largest curve is going to be 1,360.94 feet. These are the bridge railings that we are going to be using in accordance with the department specifications. We are going to be using the 32 inches F-shaped traffic railing for the inside curve and the 42 F-shape for the outside curve, and this is going to be for the total length of the bridge. And the design speed of the bridge is going to be 45 miles per hour, as specified by the department, which is also in accordance with the ASTRA manual. This is a table that they use to get to that value. We are designing between the upper range and the middle range, basing our calculations in the minimum design speed of the 2 highways connecting, which is 60 in this. Sorry. which is 60 in this case, and that gives us 45 miles per hour. Now, Alexander is going to explain to you the drainage part of the project.
Okay, guys. So all of the drainage was on in accordance to the drainage manual of the FDOT, and the drainage handbook. As you can see here, the system that we designed starts at the left side of the travel lane. And you can see here it has a bridge drain, then it connects to an 8 inches pipe, and then it goes all the way here, and it connects to this 60 inches PVC pipe. You will have, this will be all the piers that we have on the bridge. Something that we did that allows as a secondary contribution to the drainage will be the transverse grooving that was used will be used on the bridge. This provides a forced water escape from the pavement surface, and it also reduces hydroplaning. In this case, the viscous hydroplaning. You can see here we use 2 bridge drain per pier. The dimensions are here on the length is 1 feet and 11.5 inches, and wide is 1 feet and 2 inches. After the 6-inch PVC pipe, there is a 90-degree elbow at the bottom, and there is this is the proposed ground level, and there is a splash pad to minimize the soil erosion. The structure now Abel is going to continue.
Thank you. So on our preliminary presentation, we had quite a few questions about the ABC portion. So we decided to clarify that, so hopefully we'll be able to answer all your questions. So the maximum loads happened at the construction. The weight of the gantry and segments and post-tensioning cables gave them maximum axial load at construction. Also, the maximum moment happened at the point where there was the largest segment without false work. There was, I think, 12 on each side, so it would happen at the point where there was 11 assembled, and as the 12th was going in. So. All right, so the piles were 24-inch precessed concrete square piles. They're pre-stressed for bounce back, so that when they're hit, the concrete doesn't crack in tension on the rebound. Different size footprints. This was our largest one. The pile caps were huge. They were 24 by 24 by like 8, 9 tall. And so we elected to use an ABC method of, they call them cofferdam footings. I call them precast box footings because they're not true cofferdams. So the reinforcing steel would be set in place, and then each footing would be set over the reinforcing steel, and they would then be pumped full of high-performance concrete with fast setting additive, and they can be ready to be loaded in 12 hours. So they're grouted and leveled just to ensure proper alignment. This is a great photo. This is a photo of a precast pier being slid down. This is a great connection. They use these grouted couplers. There's a little clean out. You can't see it well, but they pressure grout the clean out for the connection. So the rebar ends up fully grouted, and again, a fast setting mix ready to be loaded in 12 hours. Just to be clear, that's being slid down from above onto rebar protruding from the foundation. Same thing with the pier caps, same exact grouted coupler connection. And actually right here you can see that clean out a little better. So this is the clean out below, and this is where they're going to fill it from. And the clean out below is just to make sure that it's filled. So if it's not filled, there's problems. But it's done under high pressure, so there's not usually any problems with that. This is a test specimen, so a lot of that stuff you see there is strain gauges. We do a lot of stuff in the structures lab here with ABC, so if anybody's curious about it, you can go to abc-utc.fiu.edu, and there's actually a webinar tomorrow if you sign up for it. And then the precast segmentals, the spans are long they're getting out of these. They're installed one by one, up to 200 something foot spans. The finished product, because they're precast, is beautiful. It's very aesthetically pleasing. It's very common in Florida. We see a lot of these bridges around. Requiring very minimal high work as far as like grinding and patching the joints. It's dangerous work and it's time consuming and costly, so it's a great method. And I'm going to pass over to Fabio.
Good afternoon, my name is Alonso, and today I'm going to talk about the safety and aesthetics aspects of our project. Regarding the safety aspects, we'll have anti-crane heights that won't interfere with any activity regarding the Miami International Airport. We'll also have a construction safety plan, and what it will do is it will identify any potential risk regarding the site prior to commencing any work. We'll also have safety officer in the site monitor the potential risks, and he will be able to stop any activity that he seems risky. We'll also have a comprehensive plan in order to commence activities in a safer manner in order to ensure the safety of our workers. The basis of our safety program would be to have what is called PPEs, that is personal protective equipment, to also ensure the safety of our workers and our personnel in the site. We will have OSHA 100-hour trained safety officers, OSHA 40-hour trained managers, and OSHA 8-hour trained workers. We will have dynamic evaluations, and we will have a hydration policy, as we all know that Miami is a hot climate. Regarding the aesthetics, as Abel said, the pier caps will be flared and chamfered. They will have accent panels, and the design will be of palm front. There will be a spacing of 2 inches between each panel, and the panels will begin at 1.5 feet of distance from the caps. The abutment retaining walls will also have a palm front finish, as you can see in this image. This is a palm front finish. So in general, our bridge will comply with the specifications of the FDOT's 2014 manual and the MDX enhancement manual, since they're both parties involved in this project and we need to comply with the specifications of these associations. Now I will continue with the environmental impacts.
Good afternoon, my name is Maya Molesta and I'm in charge of the environmental impacts of the project. Being completely aware of the impacts that civil engineering projects like this can cause to the environment, we will enforce the best management practices and we will achieve a total commitment of all parties to verify that all construction operations that have potential environmental impact will not begin without the correct precaution. Under the construction site, there is an artificial canal that discharges on the Little River Canal, and this canal is the habitat of the Florida manatees, which is an endangered species. We will install underwater gates to prevent them from navigating through the interconnected canals to the construction zone. Regarding water resources, drainage from construction runoff contains high levels of solids, oil, diesel, and toxic chemicals. We will implement an extensive drainage plan to pay attention to water quality of the stormwater discharge, and we will do this by the pretreatment of stormwater in retention ponds. While the water passes through the structure, we'll have devices installed that will collect any solid particles, and once they're in the ponds, since the plant naturally filters the water, before being discharged to the canal, it will be treated with chemicals, so it will be getting to the canal with a less pollution contamination that we can get. And the stormwater and surface water plants will be within accordance to the Stormwater Pollution Prevention Plan, which is dictated by the National Pollution Discharge Elimination System. Air quality. Since the biggest source of air pollution in construction is dust, we will prevent air pollution by implementing different mechanisms, such as controlling dust through water sprays that are going to be used to reduce the particles that stay floating on site, the total coverage of trucks or any equipment that contains construction material, also to prevent the dust flow, reduce the use of hazardous materials and implement the use of non-toxic paints, and also prevent the spill of toxic substance on site and the burning of materials on construction site. Regarding noise pollution is going to be very difficult to prevent or reduce it because the Bridge 9 is located nearby the Miami International Airport, meaning the noise in the area is extremely loud. So the team will follow the FDOT standard specifications for road and bridge construction and the PD&E manual also. And activities are going to be limited to certain hours to prevent possible noise outbursts.
Hi, my name is Jacobo Alanga, and I will be talking about the public awareness and quality control, public awareness, QA and QC, and lighting. So this is a consulting. We'll have multiple outreach sessions that will include the FDOT representative, construction managers, and all engineering personnel. All the information exposed in these sessions will be considered by the planners present in the meetings. We will also have a website called 826-836.com, which is an integral component of the outreach program. In this website, we will provide all the information necessary to make the public aware of any changes that we will have during the construction. We will also have Twitter account, Facebook account, and Instagram account, since a lot of people prefer to see the information in a social media than instead of going to a website itself and looking for the information. We will also have public input sessions for the public to express what any inconvenience they have had or any suggestions that they have for us during the construction process. This is a consulting quality assurance plan. This plan ensures that all labors and materials conform the FDOT, general condition, construction plans, and shop drawings. Our philosophy is that quality starts in the planning phase. There are some activities that requires more experience, that the workers require more experience than others. So for these specific workers, we'll have all current CTQP and or MOT training. The QC manual. This manual will delineate explicit procedures to be implemented by all the construction crews. All staff, including, will be familiarized with the content of the QC manual before commencing the project. Our QC staff will include the QC manager, the QC safety officer, and the QC officer. The QC manager is generally the superintendent or project manager. The QC safety officer, as Fabio said, is a very powerful man in the site, and the QC officer is in charge of the general communication. All material will be performed according to the FDOT and ASTM, and all the results of all the material will be properly documented, and if any material fail the requirements, then the QC staff will be notified immediately. Lighting. So this is a consulting will follow the ASHA standard specification for structural supports for highway signs, luminaries and traffic signals, and FHWA lighting handbook. We decided to use the standard aluminum lighting poles that will range in a height of 25 to 50 feet tall, depending on the segment they are located. The number of poles we will use are 23 in a distance of 100 each, 120 feet. So the arm length will be about 6 feet. It is good to say that we take in consideration that the airport is very near to the construction, to the bridge, so we don't want to interfere the airplanes arriving or departing the airport. We don't want the planes departing or arriving the airport to be affected by the lights of the bridge.
Good afternoon, I'm Kelvin Martinez, and I was in charge of the scheduling and estimating of the project. With the methods that we use, the ABC methods that Abel mentioned, we were able to schedule the project for a duration of 364 days, with the design phase lasting for 168 days, the construction phase for 259 days, and a time overlap of 64 days between both of these phases. Here's the actual schedule that we came up with, and we divided it in the design phase and the construction phase. And the construction phase has a pre-construction, a construction of the substructure, the construction of the superstructure, finishes, and then after the final punch list and inspection is done, we have the acceptance from the owner of the final deliverable. The milestones that we set as a company are the anticipated award of the contract, which we expect by July of 2015. Then we plan to receive the notice to proceed on November of this year. We plan to receive the notice to proceed before the complete set of plans and the design is done, because since this project has a design-build contract, we can initiate the construction before having the complete set of plans. Then on February of 2016, we plan to have the complete 100% of the design approved. Then by May of the year, we plan to have the substructure completely built and the superstructure completely built in October. Then after the finishes are done in November, we plan to have the construction phase completely done and then conduct the final punch list and the inspection to assure that the final product is up to the standards that our company has and that are expected from us. So the project closeout will be on November of 2016. The cost estimates for the project were done according to the basis of estimates of the FDOT and the master listing of pay items. We divided the cost estimate into substructure, superstructure, miscellaneous, and life cycle. And at the end we had a total cost of $12,011,098, and this corresponds to a total cost of $91.84 per square foot of the bridge. And with this, we conclude our presentation. If there are any questions, feel free to ask.
On the drainage, I saw the cutout where you had it going through the superstructure, through the column, and then eventually into dissipating pad. Where does that go? Does it go to a detention pond, retention pond? Where's the eventual outfall?
Okay, this one. Yeah, this, after this, as Maria said, it goes to a detention pond, where the water press and then it goes, like, with time, it will, basically, yeah, and,
The plan is to treat the water before it's discharged to the canal, because there's a lot of aquatic life in that canal and we do not want to harm these fishes.
All right, so it goes to the detention pond, eventually outfalls. Okay. The foundation, I saw a foundation was on piles. Is that correct? Did you guys look at drill shafts?
The original 60% plans had drilled shaft. Piles they're a little bit more convenient. Workers are more familiar with them. There's an FDOT program to design them. You literally just pop in the parameters and it pops out everything else. And then also, I think they're beneficial for moment resistance. They provide you a little more skin area for moment resistance than a couple of drill shafts will.
The traffic ratings, I saw 2 different traffic ratings for the inside and outside. Why not go with consistency?
Because we need a bigger traffic rating for the outside, since the centrifugal force is gonna, since the tangent acceleration is gonna make the car, if the driver loses control, to go outside, not inside. So that's why we want to prevent the car to go over the rating. So we put a bigger one outside the car.
Right, but I guess from the visual standpoint, where you're gonna have the smaller one, why not design the inside one with a bigger traffic rating?
We are saving money in the inside one.
I wasn't sure or how clear. How did you choose the palm fronds? I forgot.
It's a dedicated aesthetic letter that they dictated, and it has to conform with MDX. It has to blend in with all the other local highways. So they dictate to us, really.
Okay. Then just two quick comments. I think the schedule might be a little tight, and it would have helped a little bit better, I think, your overall presentation if you had a more formal introduction, because it just seems like you just went right into it. But other than that, I think you did a good job.
Thank you.